Welcome to question 1 of the Year 10 end of unit test Rates and Equilibrium higher tier. Question 1. A student investigated the effect of temperature on the rate of reaction. The picture below shows an experiment. Look, there's the student. Here's before the reaction. We've got sodium thiosulfate in the flask. We've got a cross drawn on the paper underneath the flask, so there's glass between the paper and the sodium thiosulfate solution, obviously, otherwise the paper would get wet. And we add dilute acid and we start the timer. The student stops the timer when the solution goes cloudy and she can no longer see the cross on the paper. So, what does she do? She puts the sodium thiosulfate into the conical flask. She heats the sodium thiosulfate to the required temperature because that's what she's investigating. She's investigating the effect of temperature on the rate of reaction. She put the flask on the cross, she adds the dilute hydrochloric acid and starts the stop clock. She stops the stop clock when the cross can no longer be seen, and repeat the experiment at different temperatures. Okay, so she's going to compare the rate of reaction at different temperatures. Here's the equation for the reaction. It's sodium thiosulfate, there's the formula, and that's aqueous, that's dissolved in water. We've got hydrochloric acid, there's the formula, and that's dissolved in water. It makes sodium chloride, AQ, that's dissolved in water. It makes water, well that's water, that's a liquid, H2O. It makes sulfur dioxide, which is a gas, it smells, and you can tell it's a gas because it's G for gas, and it makes sulfur, which is a solid, okay, S for solid. So that's the background, that's what we're doing. What are the questions? Right, explain why the solution goes cloudy. Well, you've never done this experiment, and there's no reason why you should know anything about it, but you've got all the information here. Okay, this is the reaction. And you can see that the reaction produces sulfur, which is solid. And the solid sulfur falls to the bottom of the flask and coats the bottom of the flask, which means you can't see through the bottom of the flask, so you can't see the cross. So for 2 marks, explain why the solution goes cloudy, because solid sulfur is produced in the reaction and is precipitated. Okay, precipitated. Sulfur precipitated. Give 2 variables the student must control to make the investigation a fair test. Right, control variables, it's SID SAM, isn't it? SID, control, independent, dependent, can't spell, dependent, SID, SAM. Control, we keep the same. Independent, we alter. Dependent, we measure. Right, what were we altering in the experiment? We were altering the temperature. What were we independent? We altered the temp. Dependent, what did we measure? Well, we measured the time for the cross to disappear. So the dependent measurement was time. Control are the things we're keeping the same. And here we've got to be really careful with our language, because we're adding 2 solutions together. We're adding sodium thiosulfate and hydrochloric acid. And when we talk about solutions, we cannot use the A word, right? We can't use the word amount, yeah? We can't use that because it's not precise enough. Because solutions have 2 aspects to them. They have the number of moles dissolved in the solution, and they have the volume of the solution. Okay, so there's two marks for this question, but 4 possible answers. So we could have the volume, okay, that is a measurement of how much, without saying the word amount, how much HCl or thiosulfate. Either of those would give you a mark, the volume of HCl or thiosulfate. But also what's critical about a solution is its concentration. Right? That's how much of the substance is dissolved in the water. So the concentration of HCl or thio. Either the concentration of HCl will get you a mark, or the concentration of thio. As soon as you put the word amount, you demonstrate to the examiner that you don't know what you're talking about, and you don't get the mark. There was 1 mark available if you didn't say either of any of those 4 things, for saying use the same cross, or make sure you stop the clock exactly the same time the cross disappears each time. But that's the booby mark, right? This is the quality mark. Volume of HCl or thiosulfate, concentration of HCl or thio. Because if I change the concentration, if I used a higher concentration of hydrochloric acid, the reaction would happen quicker. Or if I used a greater volume of sodium thiosulfate, the cross might take longer to disappear because there's more volume in the flask. Right? So it's concentration and volume that are key. Part C. State the effect that increasing the temperature of the sodium thiosulfate has on the rate of reaction. Explain this effect in terms of particles and collisions. So let's look at the marks. 4 big marks, right? So let's unpack the question. State the effect that increasing the temperature of the sodium thiosulfate solution has on the rate of the reaction. So the first mark is for stating the effect. Well, we know what effect temperature has on reactions, don't we? We could look at even if we couldn't remember, we could look at the mind map, changing temperature, right? Changing temperature, so increase temp equals increase rate of reaction. You're not going to use the arrow bits, you're going to write out the words, but you know, I'm just lazy. I don't need the marks, I've got them already. So that's our first mark. Increased temp equals increased rate of reaction. Explain this effect in terms of particles and collisions. Right, so I've got to get 3 marks, the 3 remaining marks, using with an explanation that involves particles and collisions. Well, if I increase the temp equals increase speed of particles. That's what temperature is. It's the kinetic energy of the individual particles. More temperature gives an increased speed of particles. If I've got increased speed of particles, it means an increase in the chance of a collision. Right? And because reactions require particles to collide with one another. Right? If they're moving faster, just like cars on a motorway, there's a greater chance of them colliding with one another. Still a mark to get. Okay? Increased speed of particles equals, I should have an increased mark, increased chance of collision with the activation energy. Right? So I can't just have a little weedy collision, I need a collision with enough activation energy. If you put successful collision, more chance of a successful collision, there's a chance the examiner might shine on you and give you the mark for the chance of the collision and the mark for implying that it needs to be successful, that it needs to have the activation energy. However, it's a bit risky. So for temperature questions, we're going to say increased temp, increased speed of particles. Increased speed of particles, increased chance of a collision. Increased speed of particles, increased chance of a collision with the activation energy. Then we're guaranteed to get 4 marks. Part D. How the students change the method to investigate the rate of reaction at 5 degrees C. Hardly anyone gets this, and I don't really understand why. 5 degrees C is cold, okay? It's about the temperature of the inside of a fridge. So how could they do the experiment to investigate when the rate of reaction is happening at about 5 degrees C, which is about the temperature of a fridge? Well, they could put the solutions in a fridge, or to put it another way, they could just cool the reactants to 5 degrees C.